Welcome to The Explainer. Today, we are breaking down a shift in India's technology landscape that is honestly so massive, it's literally going to shape your future job market, startup opportunities, and even national security. We're talking about a historic masterstroke here, one that marks India's official transition from just being the world's back-office engineering destination to becoming a totally self-reliant global chip design powerhouse. This is a story all about big money, brilliant minds, and fundamentally changing the global balance of tech power. Okay, let's kick things off with a paradox that might just blow your mind. What if 20% of all the world's microchip design engineers, the elite minds who create the invisible brains for Apple iPhones, NVIDIA AI servers, and Tesla electric cars, were born, raised, and educated right in India? But what if, up until now, nearly 100% of the billion-dollar intellectual property they designed was legally owned by foreign tech cartels in Silicon Valley? Owning the intellectual property, or IP, is essentially like owning the secret recipe to Coca-Cola. Just doing the engineering work, that means you're only getting paid an hourly wage to work on the bottling line. The company with the recipe makes all the real money. Well, that dynamic has just ended. India isn't just renting out its brains anymore, it's building its own chip empire. Section 1. Semicon 2.0, the 1.27 lakh crore pivot. So, the Union Cabinet has officially given the green light for the next phase of the India Semiconductor Mission. They're calling it Semicon 2.0. And to really grasp what this means for us, we have to talk about the sheer scale of this ambition. The government is backing this mission with a staggering budget of 1.27 lakh crore rupees. Just to put that into perspective, that is over 15 billion US dollars. It's a colossal war chest. This is a level of financial horsepower that completely changes the game, and it's designed to unleash a brand new way of opportunity for homegrown startups. To really understand Semicon 2.0, we kind of have to look at the transition. Think of Phase 1 as laying the physical foundation. That phase was heavily focused on building the massive physical infrastructure, the sprawling factories, the chemical plants, the testing facilities right there on Indian soil. But Phase 2? That introduces a massive high-tech pivot. It takes all that incredible financial horsepower and pours it directly into domestic chip design startups, smaller enterprises, and indigenous intellectual property creation. So we're shifting the focus from brick-and-mortar buildings to pure, high-value brainpower. Section 2. Fabs versus fabless design, the baseline. Before we get into the core of the main story, let's get our baseline facts straight. We really need to understand the fundamental divide in the tech world. It basically all comes down to the difference between manufacturing a chip and designing a chip. When most people imagine the semiconductor industry, they picture a silicon fab. Inside these multi-billion-dollar clean rooms, specialized lasers etch billions of microscopic electrical switches onto raw silicon wafers. And get this mind-bending fact, these clean rooms have to be thousands of times cleaner than a hospital operating room. Literally, a single microscopic speck of dust floating in the air can ruin millions of dollars worth of chips. Building a physical fab requires years of construction, ultra-pure water, and massive, massive capital. But here's the catch. Before a single laser can even touch a piece of silicon, someone has to create the complex architectural blueprint for that chip. And that brings us to fabless chip design. This has to happen entirely on advanced computer software before any physical manufacturing begins. The engineers are quite literally arranging billions of microscopic switches onto a digital canvas that will eventually be shrunk down to the size of a fingernail. It's basically pure software magic. Let's use a real-world analogy here because it brilliantly illustrates the dynamic. Imagine you want to build a revolutionary, hyper-efficient modern skyscraper. The Silicon Fab? That's your heavy construction contractor. They own the massive cranes, they buy the concrete, and they physically lay the bricks. But the fabless design team? They're the genius architects sitting in a studio. They calculate the structural physics, draw the floor plans, and create the master digital blueprint. You absolutely need both, but remember this. The construction contractor gets paid a one-time flat fee to build the building. The architect, on the other hand, gets their name on the building and earns all the long-term royalties. So that brings us to the crucial point, this historic economic tragedy. It's a massive brain drain happening right on domestic soil. For the past 30 years, India actually possessed the absolute best architects in the world. Global semiconductor giants set up massive research centers in cities like Bengaluru, Hyderabad, and Noida. But these brilliant engineers, they were just working as back-office talent. The foreign multinational corporations owned the structural blueprints, claimed the patents, and pocketed trillions of dollars in profit. Well, Semicon 2.0 is specifically designed to turn those Indian architects into independent studio owners who hold their own patents and actually keep the wealth at home. Section 3. The Semicon 2.0 Blueprint, from capacity to depth. Let's move into the main story of what's actually unfolding right now. Under Phase 1, the government successfully established a real, tangible physical manufacturing base. They approved 12 major projects across 6 states, bringing massive silicon fabs to Gujarat and crucial packaging facilities to Tamil Nadu, Assam, and Punjab. Honestly, it is incredibly exciting to see these physical factories actively rising from the ground after years of planning. But, as we know, a factory needs a product to build. Now, they need homegrown designs to actually power these facilities. Enter the Semicon 2.0 Blueprint. This new framework expands across 6 really comprehensive strategic pillars: deepening the design ecosystem, supply chain incentives, global fab expansion, advanced packaging, intense research and development, and talent development. While all 6 of these steps are vital to creating a self-sustaining industry, that first pillar, deepening the design ecosystem, is absolutely the most critical piece of the entire puzzle. To deepen that ecosystem, the government is tackling the absolute biggest hurdle for young startups: the tape-out. So, a tape-out is the final, incredibly high-stakes moment when a startup sends its digital blueprint over to a foundry to manufacture a physical prototype batch. And it is ridiculously expensive. Imagine spending millions of dollars just to hit print on a prototype. And if there's one single microscopic typo in your code, boom, you lose all your money. That immense fear of failure is exactly what stops startups from even trying. Through Semicon 2.0, the government is stepping in to provide direct seed money, risk capital, and subsidized access to ultra-expensive design software. It essentially acts as a safety net. It allows young Indian founders to experiment, fail, and innovate without facing instant bankruptcy. And what are these young founders building with all that risk capital? Well, they're designing specialized systems on chip, or SoCs. To understand an SoC, just use the analogy of a house again. A standard processor is basically just a pile of bricks, but an SoC, that is a fully furnished house. It's the plumbing, the electricity, the living rooms, and the foundation all built into one tiny piece of silicon. It's the memory, the graphics, and the logic packed together for highly specialized applications. We are talking about local Indian startups engineering custom chips for some of the most critical tech on the planet right now. They're designing for satellite communications, autonomous defense drones, smart electric meters, AI surveillance systems, and 5G hardware. And think about why we want local chips for things like defense drones for a second. It's entirely about national security. If you buy a chip from a foreign nation, you can never be 100% sure there isn't a secret backdoor built into it. Building them at home solves that completely. A perfect real-world example of this innovation in action is the DHRU-V64 processor. This is an advanced 64-bit compute architecture engineered natively inside India. And what does 64-bit actually mean for a beginner? Simply put, it's the gold standard for handling massive amounts of data instantly, without freezing or crashing. Engineered for industrial automation, it is a premier example of how India is completely eliminating its reliance on foreign processor designs. The remaining pillars of Semicon 2.0 reinforce all this design firepower by creating a completely closed-loop ecosystem. A closed-loop ecosystem basically means India won't just design the chip, or just build it, or just mine the materials. They're going to do all of it, end-to-end, right at home. The plan provides incentives for rare raw chemicals. It expands fabs for electric vehicles. It funds research for hyper-advanced 3-nanometer nodes. And crucially, it funds specialized college degrees to actively train over 68,000 students to do the work. Section 4. Empowering startups and the impact on your daily life. Now, let's answer the ultimate question. So what? How does a government program for semiconductor startups actually alter your daily life, your career choices, and your personal finances? First off, let's talk about the unprecedented gold rush for young engineers. We're currently seeing over 4,300 crore rupees in venture capital inflows pouring into local hardware ventures. Think about what this means for a college student watching this explainer right now, trying to pick a major. Up until now, brilliant graduates often had to just write basic software code or leave for Silicon Valley to make really good money. Semicon 2.0 changes that entirely. Choosing a career in hardware architecture is rapidly becoming one of the most lucrative and respected career paths right here at home. Second, you have to look at the sheer ambition of the national goals. By 2029, India aims to natively design and manufacture the microchips required for nearly 75% of all domestic applications. Going from near zero to 75% in just a few years, that is an absolutely insane leap. Only 25% would be imported.
And for you, the consumer, the benefits are incredibly direct. Think about the global supply chain for a minute. When local brands don't have to pay massive import taxes and international shipping fees to bring components all the way over from Taiwan, overall manufacturing costs drop significantly. This means your next 5G smartphone, your smart home appliances, and your electric vehicles will become vastly more affordable. Furthermore, these products will be highly durable and tailored specifically to withstand Indian climate conditions. It simply cuts out the middleman and makes everyday tech cheaper and better for all of us.
Section 5, Securing Digital Sovereignty, the takeaway. Which brings us to our final takeaway. Beyond the high-paying jobs and the cheaper consumer gadgets, this entire shift is a battle for absolute digital sovereignty. In the digital age, true global power isn't really about possessing physical land anymore. It's about owning the intellectual property that runs global technology. By shifting from a country that simply hires out its brilliant engineering labor to a nation that owns thousands of core semiconductor patents, India is securing its financial future. This ensures that the royalties, the massive profits, and the technological keys of tomorrow remain firmly in the hands of Indian citizens. Semicon 2.0 is a stunning leap into deep tech self-reliance. It's empowering the absolute best minds to build homegrown intellectual property that will literally power the world. So I want to leave you with this provocative thought. Now that India is aggressively investing billions to build its own chip design startups right from the ground up, do you think our young tech talent should stay in India to build local hardware companies? Or do you feel like foreign tech capitals still offer better opportunities? Drop your thoughts below, and I'll see you in the next explainer.